By the way, retro quantum entanglement. It's kind of an interesting thing that will come up eventually. You'll see. Eventually somebody will show retro quantum entanglement. But more importantly, combination of physics and biology. It's in crystalbiology. I guess it would be called now. Crystalbiology is maybe what it's called, or will be called anyway.
I'm not sure.
Okay. What happens is that you can use a particle to track back the particle's path, the path that the particle took, without knowing where the particle is or where the particle is going. It's like a recording device in a way, sort of like a recording device. But people will start thinking differently about memory very soon. Memory will be understood differently, like within a year or two. It'll be understood differently what memory really consists of, how it's retrieved, how it's used, and how it's burned in. How, in other words, how it grooves itself in. And so memory can be plastered, a tremendous amount of memory can be plastered onto a single, non-mass or mass particle or what have you, wavicle, can be implanted into a wave, so a tremendous amount of information can be put in a single burst. A microburst. And one way to transmit from one dimension to, I shouldn't say dimension, it's not correct, from one brain, one membrane, through a membrane to another membrane, and into that, from, in other words, out one membrane and into another membrane. It's a double complex form. So what you do is you strap your message in a bottle, as it were, onto an electron. You orient the electron. When you orient the electron, a counter electron orients, and you send your message at the same moment. It's a burst, it's a pulse. It's a wave interdimensional, and also of even cross-galactic, because it will work that way as well. What you're working with is spooky action at a distance, where you're forcing a particular location to respond to the location that you've hit. In order to do that, you must have discovered at least some part of what will eventually be revealed as what it will be called the grid. The grid has not yet been revealed by science. They haven't yet got hold of it. Well, they're getting there, but they haven't yet got hold of it to understand what the grid really is. Once they understand what the grid is, they'll be able to predict the exact point at which you can have a vector interaction between 2 points without particles being there. As a matter of fact, at some point, the particles are eventually transcended. Oh, I did want to mention what QED. I was talking about this orb that I have done. It's called QED. QED is quantum entanglement disentanglement. It's a connect-disconnect type of toggle dealy. And I set it up in the same space where you would normally go for an oracle, but it's different. It's a differentness to it. It's not the oracle space, but it's sort of similar to it because it's based on the same architecture. But it is a different space, you'll notice. And quantum entanglement usually happens by accident. Quantum disentanglement usually happens on purpose. Some quantum entanglement happens on purpose, very little, but some does. And quantum entanglement for this universe is pretty unavoidable, because pre-Big Bang, we were shoulder to shoulder. So there's plenty of opportunity for quantum entanglement in this, in something the size of a mustard seed, which is what the entire contents of the universe pack into pre-Big Bang.
But the quantum entanglement's going to be like any, I don't know, spectra or spread. There's going to a given object is going to have background entanglement with the whole of creation, and then it's also going to have entanglement with some of the, separate but various things that it's been involved with during its passage. So it's not just one thing or another.
That's right.
It's going to be layers and layers and over layers.
Yeah. Complex entanglement is actually a complex structure of simple connected things. The connections are simple. They're straightforward. They're simple connected. They don't have complex formation. But there's a very complex web of them. And that complex web can look awesomely difficult to deal with. But it isn't, actually. Surprisingly, it isn't. We're going to talk about bundling, how to bundle entire groups of problematic areas and just throw them out the space log, basically.